Sorry, I got into something again. All right. Good evening, everyone. So, okay, I think I'm good now. Okay, so before we start, this Friday we will not have any class, RAC related class. Okay, so but those who were dealing with some Golden Gate related issues, we can set up 1 or 2 hours on Friday to discuss about any issue you have. Golden Gate related, especially. Simply because next week, my availability will vary a lot. I can validate my presence only on Monday. The other days, I'm not sure I will be around. So, and that's why I want to round up everything for Oracle Golden Gate. Those who are having issues, right? So the class is 100% optional. Please feel free not to attend. Okay, if you cannot attend. If you feel like you don't need that, you don't even need that. It's just for those who configure Oracle Golden Gate, and maybe after some time they try and they are maybe facing some issues or they have some questions for me, then I'm open to answer. So the length of the class will depend on how many questions or how many problems we have. But normally it is set for 3 hours, right? But if people are sleepy, no questions, so we can spend 30 minutes. If people are active, we can spend 1 hour, 2 hours, 3 hours. Everything depends on how active or how many problems people will be having. So yeah, So that means that's what we have this Friday. And Monday will be a class more technical, 90% practical, because we cover most of the remaining part today. If you come back Monday, just take maybe some questions. But I will make sure that on Monday, myself, I've configured RAC as well, so that we just, go through the technicals on Monday. And Monday as well, I'll make sure, I'm not sure I'll be working Monday. So it means that we can have 4 hours class Monday. That means starting from 5 all the way till 9 p.m. I'm not sure I'll be working on Monday. So fully technical. And yeah, that's what we've been doing so far. And I discussed with Prof about, the next step. How long I still have to spend with you guys. I still have to stay with you guys. Okay, so any question on what we did last class? Before we proceed, I'm open. Any question, not even what we did last class, any question, any doubt, anything on RAC, just ask, please. I'm open. Anything? If there's no question, that means nobody studied.
Okay.
I got just one question. And you
Yes.
say when we go create the database to Oracle RAC, we got 2 types of the database. We got database administrator, and we got the police database.
Policy manage.
Policy managed database. Thank you. And the database administrator, we go select the nodes that go running, and the database police, we go put the nodes inside the pool.
No. So administrative manage means you will choose on which node you want the database to run. Let's assume the RAC is a RAC 4 node or a RAC 10 node, right?
Yes.
So that means the cluster is running on 10 nodes, for instance. So if it's administrative manage on GBCA, if you select administrative manage, GBCA will give you the list of all those nodes. So you have to check the box. You check the box where you want the database to run. Does it make sense? So you are choosing where you want the database to run. Administrative manage. Does it make sense?
Yes.
So now if you select policy manage on GBCA,
yes,
GBCA now will display all the server pools that have been created in that environment. So in that scenario now, you will be choosing on which server pool you want the database to run on. So if there is no server pool, you cannot create an administrative managed database. So there should be a server pool already existing.
Okay.
Does it make sense? So now you can select which server pool you want the database to run on. The database will run on that server pool only.
Okay, thank you. You give the answer for my first question, because I was thinking about to ask you the server pool if you was go create before or you go create at the same time. And the second question, you say, and the server pool, the nodes can be running, can be just was running to the server pool E, it can go to the server pool B, the node. But you say, and if we do to the database administrator, you have to move the nodes manually. But the pool, I ask about the pool. Maybe you give an example by like the cell database. You give example about this is Thanksgiving. Is it like a lot of people using the same database because you buy some stuff and you consume a lot of resource, but it's going to change automatically, or you have to go off there only like change manually, say, oh, this one the time we go use we go have more customers and we go use more the resources. I need to increase more the note for this support. You go do this one manually, or I don't know. That's why it was just confused because
No,
I
that
know
one,
the
that
other
one
one
be
is
done
manually.
manually. That will be done manually, right? Since you need it, you can now just grab it from somewhere and go and add it on that tool. It's done manually.
But what time is going to be automatic? What time is going to be you go move it itself?
Automatic,
Yes.
automatic when it lost, when for any reason, right?
Yes, sir.
It lost, you know, maybe when a new node, you are trying to add a new node, okay, to the entire cluster, So automatically that node will join them, you know, based on the priority. Does it make sense? That one is done automatically. And also, if the most important spool lost maybe one of his nodes or two of his nodes, automatically is going to get it from another server pool. So that is what is done automatically. But if for any reason everything is fine, and all the server pool are working fine, perfectly, and you want to increase the amount of resources of one pool, you can do that manually.
Thank you so much. Thank you so much. I think maybe I will come back later.
That's it for your question, Mr. Fari.
Excuse me?
That's it for your questions. Are you good for your questions?
I think about the one, I forget one. I'm thinking about one now for the other one. Maybe if it's somebody got a question, can ask you.
Take your time. I'm here, no problem.
Thank you.
Yes.
Yes, I have a question.
Yes, Mr. Akodi.
So I don't know, could you throw more light on the how they call it? On the with the redundancy, like we're talking about the external, the high, and the normal. Right.
We talk about it today.
Okay. All right. Because I really didn't get it.
I talk about it in the morning. I talk about it on the evening. Okay, that's ASM.
Okay, thank you. All right. And just to confirm, I wanted to let you know concerning the Golden Gate, the bidirectional. For the looping, I used the parameter translog exclude user, and okay. I was able to resolve the looping.
Okay, you know the translog option, right?
Yeah, the translog exclude user.
Yeah.
Yeah.
There are multiple ways. That's good. If it work for you, then just document it. That's very good. Translog option is good as well.
Okay.
If someone else tells you that he or she use trace table, don't say that no. Okay.
Yeah.
Also, yeah. Very good. Okay. Any other question for me, guys? Please. I need questions. Otherwise, it means you guys are not following me in this class.
Yes, I have another question.
Please.
Okay. When we installing the Golden Gate Home or the grid interface, are we gonna install it on both nodes or just on one node?
The grid infrastructure?
Yes.
When you watch the video, the guy will install it on one node only.
Right. I noticed.
Okay. Yes, because at the setup, right, you guys will enable SSH. Okay. Yeah. Serverless SSH. That means you can just SSH without having to put the password. Passwordless SSH. Okay. So once you set up the SSH, automatically, okay, remotely the configuration will also take effect on the target on the second node. Okay. So if you watch the video, you see at some point when he's configuring the grid infrastructure, if I remember, at some point when he calls the graphical user interface of the grid infrastructure, he has to set up the SSH before he can proceed to other steps. So that's why we need that. Automatically, the tool, after configuring the grid infrastructure on node 1, will move show and configure the good infrastructure. But before that, there are some prerequisites that should be done on both nodes. You have to make sure that you created the users on both nodes, you created the operating system group, you gave them the permission, you created a profile. Those are the prerequisites that should be done by the sysadmin. They should prepare all the RAC servers. Okay. But now the infrastructure, you can install it on one location and it will be installed on other remote locations as well automatically. Okay.
Okay, that's fair. And the other question, what about the IP addresses? How are we gonna know about the IP addresses of the individual servers?
Because it's already configured on the GNS, the network guy. He's the one who did everything, okay? But ahead of the time, they configure those IP addresses with the name, okay? So what happened is that those IP addresses now have to be added to the etc/host file in order for them to be used. So when you guys be watching those videos, even now, go to your server, you will see those scripts the guys is running. Open the first script. It's RAC_setup something. Open it and see what is in that script. You will see that he just put some command together. He just put some steps together and he made them as a form of shell script. And one of those steps he will be adding those IP addresses to the etc/host file. We'll be adding the private IP, the public IP, the virtual IP, not the scan, because the scan can be added later on. Okay, so those IP addresses are already configured and resolved with the related domain name ahead of the time. Okay, so they just had to add it now to the etc/host file for the customer to be able to access. But ahead of the time, they did all the resolution already. I don't know if it makes sense what I just said.
Yeah, it makes sense. So probably after we must have run the those SH script, like those prerequisite script. And if we cut the host file, we're gonna see those addresses.
You don't even have to wait all the way till you cut the host file.
I'm talking about like the VIP address, and because he really didn't use the private address, he just used the public address and the VIP address.
Let me see if I can. I don't know if I open it. Let me see. Let me see something. Ms. Renata, please, can you allow me to share my screen, please? Thank you. Are you here? Okay, thank you. I'm good. Okay. This is how that script will be looking like. No. I changed it, okay? I started setting up for 12C. So, but a typical input review, this is how the beginning will look like. So the etc/host is where all the network files are located. So this will be the entries of that. So you can see that for the private IP, this is the IP address, is the name, the domain name that has already been created and resolved with this address. Same thing for the private IP address of the second node. This is the IP, this is the domain, this is the alias. But this is the VIP. This is the VIP of the first node. This is the VIP of the second node. This is the public IP of the first node, the public IP of the second node. So all this stuff have already been resolved behind the scene. They just have to come and add it now to the etc/host. So that means what? After you run this script, right? If you cut /etc/host, you will see all those files inside. So it's done ahead of the time by the network team. You guys know that they have to be picking IP addresses all over the places, making sure that they have IP addresses, a range of IP addresses available. They pick those IP addresses and they use it to configure the network. That is something else, right? The way they calculate it is something else. It's not the scope of this course. But all this stuff, name and IP address are resolved ahead of the time, before. And once it is done, now they provide it to you, the sysadmin. The sysadmin takes care of it. Once the sysadmin is done, now you, the GBA, you come and do your own part. So that's why most of the team open the script, guys, and understand what you can understand. There are some commands you may not understand. It's totally fine. Like group add, I know that group add, you guys don't know how to create a group, GBA group. This is how they create it. This is a sysadmin job. This is how they create a Oracle user with the privileges. It's not the scope of the code, but that is what the script contains. Okay, so I hope I answered your question when it comes to IP addresses.
Yes, that was good. Thank you.
All right, no problem. Any question?
Yes, if you could please just walk us through that slide 29 again, just like step by step.
29.
Yes,
Yeah, slide 29. If you could just, yeah.
Yeah.
Thank you.
Okay. I'm doing it because it is very, very, very important. Okay. When you are going to an interview, get prepared to that type of question. This question even, when it comes to how the connection is routed. And I believe I will just do that again. If you have any question, ask me if I can help. If I can throw more light, I will do that. Okay. So before I get here, I explain the concept of server pool. And I say that with server pool, you have multiple servers, right? Multiple server part of the cluster where, and I said that in the TNSName.aura of the client, they may need to specify all those servers on their TNS name. That means if you have 10 servers, 10 hosts, 10 nodes, right, on the cluster, they have to specify all those nodes on the cluster, on that local TNS name. That means they will put the first line for the VIP1, VIP2, and so on. It was looking like this, a little bit like this, right? So if there are 10, they have to put 10 entries. The more nodes you have, the more nodes you add to the cluster, more entry you have to add here on the local TNS name.aura. If you remove it, if a node departs from the cluster, you also have to come manually and remove it from this entry, okay, from this TNS name. So that was the biggest issue we were facing with the VIP, whenever we're using the VIP to connect, okay? I hope we all remember the benefit of using the VIP instead of the public IP address. I hope so, right? And I want someone to just tell me why VIP were better than public IP. Why is it more benefit? Why is it more beneficial to use VIP than public IP addresses? One person.
I think last time you said before what the application, what the DBA if I'm not making mistake, application team was try to connect to, for example, for node 1. If the node 1 is cannot start up and is go down, you have to wait by 15 minutes to go start up node 2. That's you go spend more time. The database will be downtown. And you give it the second example. You say if the application team connect, for example, for node 1, and the database go down, a VIP 1 go take the service name to instance to node 2, and the DC VIP is go managing the connect to the node 1 to the node 2 via VIP connects. That's a couple of the
Yes, I you have the idea. Definitely, you understand the point. Okay. Maybe the way you are just providing the information, is a bit more complicated. But you understand what's happening. You understood 100% what was happening. And that's correct. With the public IP, whenever you're using the regular public IP address, okay, if that node goes down or something happens to that node, those connection, we have to wait 10 minutes. That's a default one. 10 minute TCP timeout before they can even receive an error that something went wrong to the node. And they can now try to connect again before maybe Oracle will redirect them to the next available node. So that was the main issue we're having with public IP. Now virtual IP came on 11.0 release 2 to fix that issue, right? So virtual IP, if something happens to a node, the VIP of that node will move all the connection to the next available node, right? And that is what we have reduced the downtime. So people will not have to wait those 10 minutes. And that transition is what I call transparent application failover. It's not done by default. Despite the fact that you have VIP, you also have to enable transparent application failover at the service level and also on the client level. So that is something you should enable. But once you enable it, the VIP can definitely contribute to transparently failover your connections from one node to the other one in case there's anything wrong with that node. Okay, so that was the benefit of the VIP, okay, over the public IP address. So, but I came now with the server pool. I said, server pool now, you guys can see here on my screen that there are multiple, in case, whenever you have multiple servers, right? So it means that is how a typical TNS name will look like. And the issue is what? If a node is added to the cluster, you have to notify every single member to go on this local TNS and update it and add that entry or remove the entry if the node departs from the cluster. So you have to bother them, right? Bother people to be adding or removing entries on that from the TNS name.aura. Okay. So it makes the job a bit complicated, right? So because things are moving. So what is scan? And also with the VIP, another problem with the VIP is that once you were especially using dedicated connectivity, not server pool, right? Even dedicated connectivity, you can connect sequentially. That means what? If you are trying to connect, there's no load balancing. So if you want to connect, you have a 8-node rack like this, you can only try to connect to node 1 first before you try to go to node 2, before you try to go to node 3, before you try to go to node 4. So the connection won't be balanced, right? You won't be able to decide on which node you want to connect to, or you won't be redirected to the least loaded one. you have to start to the first node first, to the first one, the first VIP, before you try the second VIP, before you try the third VIP. So it means that in this scenario, one node can be more loaded than the other one, right? Far more loaded than the other one. Because people will always be trying the first one before they move to the second. Now, scan, in addition to what I just explained, and also the problem of adding or removing nodes from the local chain to the Aura, scan came to resolve that issue. Moving forward, the network team, behind the scene, right, as they did for the public and private IP address, they can also do that for the scan. Instead of resolving one host name for one IP, like I show you on the AGC/host now, they will resolve one host name with multiple addresses, with multiple IP addresses. Okay, so an example could be any platform you guys are using online, Udemy or Google or Facebook. You just type facebook.com, but behind facebook.com, there are multiple addresses behind, multiple servers running behind that simple word, facebook.com. Okay, so, and why do we need that? You know, you, the client, you no longer have to change anything. Just that name can help you to connect. So it means that moving forward, you will just give one name to the application team. The name will be the scan name. And the scan now will come with 3 components. It comes with a domain name that will be created by the network team. It comes with, by default, 3 IP addresses for that domain. That means behind that domain name are attached 3 IP addresses, okay? And each IP address has a one-to-one relationship with another component called scan listener. So it means we have 3 main components: the scan name, the scan IPs, and the scan listeners. The scan name is the name you give to the application team for them to add on their local TNS. The scan IPs are actually what are resolved, okay? What are the IP addresses attached to that domain name you provided? And the scan listener has a one-to-one relationship with every single scan IP. So if I have 3 scan IP, I also have 3 scan listeners. Okay, one-to-one relationship. So the domain name and the IPs are resolved on a server called DNS server, and that is done by the network team. They resolve it on the DNS server. They configure it ahead of the time. That's not their job. They should prepare that for you. Okay, they know how to do the mapping. They resolve the host name and the IP addresses. Now, the third component, that is the scan listener, is the main component in charge of monitoring the load on each server. It's there for load balancing. What do I mean by that? The scan listener allocate connection to the nodes based on the load on that server, on that node, okay? So the scan listener will check a component called load balancer advisor. The load balancer advisor is that component that knows the load allocation on each node. So that means it's an advisor, right? An advisor will advise you, will give you some details. It's like if you are contacting the memory advisor, he will advise you on the best memory to allocate. Okay, so the scan listener has to contact the load balancer advisor in order to know the allocation or the load allocation on each node. And once the scan listener from the load balancer advisor will detect the least loaded node, that is where the scan listener will send the connection. So how will the connection move? You are on a laptop, you use the local TNS name. On the local TNS name, you put the scan name now. You try to connect. Once you are trying to connect, the first barrier you hit is the DNS server. That DNS server will see that host name or that domain name, that is the scan name, and try to see if we have IP addresses resolved. Okay, if you have IP addresses attached to that name. If yes, the DNS server now will assign to your connection one of those IP addresses. But now, let's know something. It's not done randomly. Those IP addresses are not assigned randomly. They are assigned in a round-robin manner. What do I mean by round-robin? It means that if user 1 is trying to connect, the DNS server will give IP address 1 to that user 1. User 2 is trying to connect, the DNS server will give IP address number 2. User 3 is trying to connect, the DNS server will give IP address number 3. User 4 is trying to connect, the DNS server will come back to IP address number 1. User 5, the DNS server will give IP number 2. User 6, the DNS server will give IP number 3. User 7, the DNS server will give IP number 1 again. So it's round robin. 1, 2, 3, 1. Okay? 1, 2, 3. It comes back to 1, 2, 3. It comes back to 1, 2, 3. So that is how connections are allocated. So once you try to connect, it will give you one of those IP addresses that are already resolved in the DNS server. Because each IP address is attached to a unique scan listener, automatically your connection will be forwarded to that scan listener, which is a remote listener. The scan listener now will now consult the load balancer advisor to know the least loaded node and can now forward your connection to the local listener of the least loaded node. And you guys know, I think you guys know what happened after the listener, the local listener, right? The local listener will check the port, the protocol, the service name, and the host. If everything is fine, you are authenticated and a new session is created for you on that server and you proceed. I don't know if you guys understand the transition from the local machine all the way to the server. It makes sense?
Yes, sir.
Any question? Okay, so by default, we have 3 IP addresses. You can have more, okay? You can have 5, you can have 7, you can have 4, you can have 6. There's number, okay? That one, I'm not sure there's a protocol on that one, but the default is 3, okay? And I forgot to ask this question in the morning class, but it's an interview question. In a RAC 2 node, what's the total number of IP addresses in a RAC 2 node? I remember for this question in the past, the person who, when I was in class, the person who provided the right answer, I sent a cash app to the person at that time. So
is it still available? Do you do cash app?
I usually do cash app. I never did a cash app with you guys. Yeah, so because okay, who can try to answer that question? A RAC 2 node, what's the total number of IP addresses in a RAC 2 node? And I'm taking suggestions. That means I have node 1, I have node 2. In a RAC 2 node, by default, what's the total number of IP addresses in a RAC 2 node?
6.
6.
So I'm sure.
Justification. What is the where is the 6 coming from?
I'll go with 1.
Now, okay, let me try the person who says 6, right? Tell me how you find out 6. You got the 6.
I think earlier you said on each node, by default, we have 3. You can have 3 IP addresses.
What and what? What type of IP address? Split those 3. What and what?
Public, private, and
VIP.
Public, yeah, VIP. Public,
Okay.
private, and VIP.
So that means 1 public, 1 private, and 1 VIP.
Yeah.
For each node, 1 public, 1 private, 1. Okay, I understand where your 6 is coming from. So it makes 3 plus 3. Okay. Who else?
So I changed my. It should be 2 IP addresses.
What and what and what? Tell me.
It should be the VIP and the public address.
For each node, or the total is 2?
Yeah, the total is 2. I will go with 2 because you know the VIP will contain basically the of course it's going to contain the public address of the two nodes. That should be 1. And
okay, you say 1 public plus 1 what?
no, I say 1 visual.
Okay, 1 visual.
1 visual and one private. So that would be 2. Because the visual will contain the public address, the public addresses.
Okay. Any other suggestion?
I think by
Yeah.
I think by 5.
5.
Yes.
Okay. Where are those 5 coming from?
Okay, I thank you, but not 1. We got public and the VIP and not 1 and not 2 equal public and the the 1 connection, the private connection between the nodes, because the private connections is serving for the connected the nodes, the private connection.
Okay, that means you have 2 public plus 2 virtual.
Yes.
Plus 1 private.
1 private.
Makes 5.
Take 5.
Okay. Good. Any other suggestion?
Yes, sir. I think there should be 6. I agree with the first answer.
Okay. You are still going with the first one as well. 6.
Yeah.
Okay. Another suggestion?
Eight.
8. Where are those 8 coming from?
You have 2 public, 2 private, 2 virtual, and 3 scan.
Makes how many?
Oh, 7. Wait,
That's
1, 2,
9.
4.
So you say 2 public,
9. Yes.
2 private,
2
2 virtual,
Yeah.
plus what?
3 scan.
3 scan. It makes 9. Okay. That's your answer, right? Okay. Any other suggestion?
Titan, can you show the slide again?
I just talk about 2 nodes, right?
No. The slide you showed earlier on the presentation.
This one? Or the architecture?
Yeah, this one.
Okay. There is someone very close to the answer. Who wants to make any modification? That's it?
I will add 2 to Anita, 9. I'll add the listener. If you just have the 2 listeners.
So it means you add 2 more to what Anita proposed, right?
Yes.
So it means you just add again 2 listeners. It makes 11. Right? Okay, 2 local listeners, IP, okay. That's it?
Hold on, can we just think some more?
Yes, Anita, go ahead. You want to change something or you're good?
Well, I'm thinking.
Okay.
Did you? No, you did not. Did you say that each node has 3 scan IPs?
I never said that.
Oh, okay.
You good? Can we stop here or still need some time to think?
Give us 1 minute.
Okay, bye.
Gatan.
Yes, Mr. President.
If I say 3, if I modify for 3,
Okay, how many do you say before? 5?
I say 5.
Okay, the 3 are coming from where, please?
Yes, because you say the API is the is the backup for the public.
Okay.
It says
Okay. So you want to remove public.
yeah, I think it's the backup the public. If it's a backup for the public, I think the public and the VIP is the same thing, because when the VIP the public is running, we not need it. If the public is go down, that's why we're going to need it. That's
Okay.
I think one and
It makes 3, right?
yeah.
2 VIP, 1 private, which makes 3. All right. Anything else? Any other suggestion?
Yeah, I suggest 2 private, 2 public, and 1 virtual.
Yeah. Let me see. Okay. You don't have the suggestion here. Okay, let me type it. Let me write it down. 2
private,
private,
2
2
public,
public,
and 1 virtual.
1 virtual.
That's how I said before.
Makes 5, right?
Yes.
Thank you. Any other suggestion? Okay. So I can stop here, right? So,
Can I try again?
yes, go ahead, Anita.
Okay, I'll say 1 public. 1 public, 2 private, 2 virtual, and 3 scan.
So you are removing the 2 public. It becomes now 1. That means the total make 8, right? That's correct? Or are you sure?
No, never mind. Can you take it out, please? I'll stick to 9.
Gaita,
Yes. Yes, Mr. Fadi.
can you repeat your question?
I just want the total number of IP addresses in a RAC 2 node.
What to note?
Yeah, that was the question.
If we say just 1, the private.
It's fine. That's your answer, right?
Yeah, I think, well, if you say just 1, the private.
So you want me to read all these? I'll put only 1.
Yeah, you do the communication between not 1, not 2.
So it means 1. Okay. That's it, right?
Yes, Mr. Gata.
Thank you. Anissa, send me your cash app number on my personal phone number.
Oh, that's correct. Thank you. Okay.
Yeah, so we have 9, okay? Simply because I think I explained it last class that each node has 1 private, 1 public, 1 virtual. First of all, right? So the first suggestion was really good, like this, right? The private IP is what allows the I think I even draw a picture. Let me see.
Oh, each scan.
I draw something here. Now let me see. No, that was server put. You see, no, I draw something somewhere. That's class. Maybe it's no longer here, right? But I draw something and I put all the IP addresses. And I even made there was a picture like this. the private of one was communicating with the private of another one. Oh, that is public, sorry. So the private, each node has its own private, okay? That's what helps for the communication through the interconnect. Each node has its own public and also its own virtual. Even though you are not using the public, but the public is still there. And the virtual is there as well. Now, I just talked about the scan, and I said that by default, we have 3 scans. That means what? If each node has one public, one virtual, you can just make a calculation, right? Plus the 3 scan IP addresses I made mention of now. So it means the total is 3. These are these 3 plus the other 3 of the node 2 plus the 3 scan, which are makes 9. She's very correct because she explained it perfectly. The way she described it is perfect, right? That's why I will give her the money, right? Because she understood what she was saying. I wanted to see whether she was sure. She just wanted to, to change her mind as soon as I tell her to double check, right? So we can see here that each node will have 1 public. So that means it makes a total of 2 public. Each node has its own private, make a total of 2 private. Each node has its own virtual, make a total of 2 virtual. And the 3 scan make a total of 9. Okay? So the formula is 3n plus 3. N is the number of nodes.
I got a question.
Yes.
So how many scan each node have by default, you said?
The scan doesn't reside on a node. The scan is a remote, the scan listener, or the scan IP are a remote component. So it can run on each node, but it's not owned by a node. So we have 3 scan, right? You will be able to see those scans running either on node 1 or on node 2. But they are not dedicated to that particular node. You can just see them from the node, right? But it doesn't mean that that node actually owns the scan. We call them remote listeners. Let me take an example. You can have this 3 scan, but just this 3 scan can manage 8 RAC nodes. It means that those 3 scans will not run on all the 8 at a time. Does it make sense? You'll be able to see those 3 scans only from 3 of them. But remotely, they will monitor other nodes. So the scan is not owned by any node. It's not local to a node. That's why you can easily relocate one scan from one node to another one. Okay? So you guys should know that. So we have just 3 scans. They run wherever they want to run, but they help to transfer connections to the least loaded node. Does it make sense?
Yes, sir.
Good.
Mr. Gata.
Yes.
Who make the load balancing for the scan?
The scan listener is the one to check to ensure the load balancing. The scan listener is the component of the scan that takes care of load balancing. Okay?
Okay.
Yeah. So what happens if you forget to remove one of the TNS entry if you get rid of one of the nodes?
No, with the TNS entry anymore, you no longer have TNS entry for each node. You just put the scan name on the TNS node order. Like this. Only one scan name like this. Only one name. You see here that I never specify a node anymore. There's no node I specify. I just specify a single name. But behind this name, you have all those IP addresses. This is the only thing you need to provide to the application team now. That's the only thing they need on the TNS name of Aura. But on the server side, this name has been resolved with 3 IP addresses. So for them to create a session on the server, they should just use the right scan name. If the spelling is good, they'll be able to connect. No need to be updating the TNS name of Aura again. I don't know if it makes sense.
Yes, it does.
Okay. We good?
Yes, sir.
Okay. Let me finish with Mr. Anita first, okay? Before I do you send me that? I don't want to forget, right? Just send me the Cash App, the Cash App name. That's it. If you have Cash App, if you don't, just send me the Zelle or anything.
Anita, if you don't have any number, you can use my number.
Yeah, I'm just trying to find your number.
So when you have it, okay, just send it to me, okay? I forward it to you.
Okay.
So
I just did.
okay.
But don't forget those who try too.
I agree with you.
It's Easter, you can remember everybody.
Okay, so okay, I found you.
There's no second prize.
All right, so any other question for me?
I have Cash App too.
I know.
No, your Cash App is blocked.
Okay, any question? So I hope you understood the concept of scan. How connections are redirected from the local machine to the server. Okay. So today we are going to
Thank you. I received it. Thank you.
Okay, no problem. So today we are going to proceed with global resource directory and how a block move around from one instance to another one and the different block status. And after that, we'll talk about the ASN, okay, before I log out. So we all know that each database instance, right, has a memory and background processes, and one type of memory is the buffer cache. We all know the buffer cache. You all know that buffer cache is from where we have blocks, data blocks, right? That's where you can make the blocks dirty and so on. And right now we have multiple instances, correct? So it means that we have multiple buffer cache. Instance 1 will have its own buffer cache. Instance 2 will have its own buffer cache. And instance 3 will have its own buffer cache. But now, remember last time I told you guys that nodes are communicating. Okay. How, if I'm looking for a block, how will instance 3 knows that the block is actually on instance 1 or on instance 2? There should be something, right, to allow that communication, right? And we said that the clusterware is what was allowing nodes to communicate and to share data. Okay, so now in RAC, when they install the grid infrastructure, and the clusterware also will come with a component called the global resource directory. What does it mean? It means that now we have a global buffer cache. Okay, so now in this scenario, all those buffer cache are behaving as a single buffer cache. So the buffer cache now, each of them have their local buffer cache, but now there's a global buffer cache. So why? Because if an instance needs a block, you can easily grab it from another instance. Because the global buffer cache, they can grab some information from there, and they can know where the block is located. That's the concept of cache fusion. So with cache fusion now, it's like you have one single buffer cache from the outside loop, okay? From outside, it's like it's one buffer cache. Simply because if you're on instance 1, you can get the block owned by instance 2 or instance 3. Because instances are communicating. Okay? So, but now let's go a bit deeper, how it works. How that communication actually works. So the global resource directory actually keeps some information, some block-related information. What do I mean by that? Each block has the master. Each block in Oracle now, Oracle RAC, has a master instance. In other words, each instance owns one or multiple blocks. Owning that block means what? If I own that block, it means that every time I know where my block is located, I know where that block resides, whether it resides on the disk or on my own instance or in any other instance. But because I'm the owner of that block, I know where it is located. Each block has a master now, a master instance. So what and how does it work? If assuming that instance 1 is the master instance of block number 1, if instance 2, there's someone trying to request for the block, right, from instance 2, instance 2 now, the first area instance 2 is going to check will be the global resource directory, because in the global resource directory, you can know who is the owner of which block. The metadata is stored there. So instance 2 will check the global resource directory. And we detect that the master of the block instance 2 is looking for is actually instance 1. Now instance 2 can request for the block. Okay? Instance 2 now will request for the block, right? We ask instance 1, please, I need your block. And instance 1 now, we just forward the block to instance 2. If instance 1 has it on its own instance, right, on its own buffer cache, instance 1 will send it to instance 2. If instance 1 doesn't have it, instance 1 will show instance 2 where the block is actually located. And instance 2 can go and get it there. If the block is on a disk, instance 1 will tell instance 2, my block is on a disk. Go and read it from the disk. If the block is located in a different instance, instance 1 will instruct that instance to send it to instance 2.
Hello.
So
But
this scenario is valid for every single
can I
block.
get the jump start?
Every single block. Now, when you get a block that you don't own, right, you become the shadow instance of that block. There's still a master. So there's still, the owner of the block is still there, right? You who borrow the block, right, who got a copy of the block, and you are working on with that block, you become a shadow instance. But at some point, you can become the master instance in some rare scenarios. That means what? The ownership of a block can change. It's not static. It's not like if you are the master of this instance, you'll be the master forever. You can be, another instance can become the master of a block if that instance is requesting for the block more frequently than the instance that owns that block. So if I need a block more than you, why are you still the master of the block? I need it more than you, right? I'm requesting for the block every time. Let's just change the ownership. Another scenario could be that the master of the block leaves the cluster. When you leave the cluster, you give the ownership to other people, right? Whatever you were owning, you share it with the surviving instances. Okay? So that is how blocks are managed in RAC. Does it make sense? So moving forward, if I have a session that is running on any instance, that session needs a block. Through the global resource directory, that instance will know who is the owner of the block is looking for, and it can just go and request for the block from the master instance.
Excuse me, sir. So during the request, if that block is being written to, what will happen then?
If the block is being what, please?
Written to.
It doesn't matter, right? It doesn't change anything. Even if you request for the block and you update it, I'm still the owner of the block. I'm still the master of the block. Does it make sense? So you will become the master of the block only if you have been using the block more than me, more frequently. Then we switch the ownership. It makes sense, Mr. Devon?
Yes, it does.
Good. Are you getting the concept of global resource directory? Because you have an interview question for sure when you get to RAC, more than 80% of the time they ask you cache fusion.
Mr. Gata, go back one more time, please.
Okay. I just said that, moving forward in the outside loop, the cache fusion is like you have now one global buffer cache shared by all the instances. Okay, so moving forward, if instance 1 needs something from instance 2, there's a global area called global resource directory, from where instance 1 will know the location of the block and can request for the block from there. Okay, that location is the global resource directory. So the global resource directory will tell you if you need the block. It will tell you actually where the block is located and who is the master of the block. So once you know who is the master of the block, you can just request for the block, right? You can ask the master, please, I need a copy of your block. Now the master will just send a copy to you if that master actually has it. If the master doesn't have it, it will tell you at least where its block is located. So you can just get it from there, from the location where the master instance will direct you. You don't ask that way, the way I'm saying, right? That's what happened in the background, basically. You, the end user, you don't know that there's a global buffer cache somewhere. You are just running your query. You just get your result. You don't know what's happening behind. But behind there's a cache fusion. Buffer cache are sharing blocks. Blocks can move from one buffer cache to another buffer cache. Okay? From one instance to another instance through the interconnect. Why? Because we have a global buffer cache now from where one instance can request for the block if another instance has it. I don't know if it makes sense.
Mr. Kata, does mean like the instance have the only buffer cache, but we got and the RAC we got one is the big one for share for all of our instances running for this maybe I can say pool or this RAC.
Each instance has its own buffer cache, and in addition to that, we have a global buffer cache.
Global buffer cache, okay.
Yeah. And that is what helps the communication, allows the communication. Otherwise, they will be isolated, right? One instance will not know what's happening on another instance. But having that global buffer cache, one instance will know what's happening on another instance, and one instance can easily request for a block from another instance. Okay? That's why whenever you are moving, you are converting a single instance database into a RAC database, they ask you to add more buffer cache to increase the buffer cache, because the new global resource directory will need some more space in your existing buffer cache. So you add 10% more, okay? If the buffer cache was 10 megabytes, okay? You may need to add 10% of those 10 megabytes in order to accommodate the global resource directory, okay?
Yeah, Mr. Kata, that's mean like in the global resource directory, we got the DB writer of the two to write it to the disk?
No, very good question. We don't have the DB writer on the global resource directory. We just have the global cache service, global enqueue service. We just have processes related only to the cluster web. The DB writer is still on each buffer cache, local buffer cache. The DB writer is not part of the global buffer cache, okay? Those processes in the global buffer cache are just the processes responsible for copying a block from one buffer cache to another one.
Yeah, thank you.
So they're just there to monitor the block transfer. And those processes are specific to the grid infrastructure. They are not existing process of Oracle you guys are familiar with. So that's why you hear about the LMS process, the global cache service, okay, which is responsible for supervising the block transfer from one instance to another one. And it makes sense.
It makes sense. It makes sense. Thank you.
Yeah, no problem. So now I will explain the block status, because the block now can have multiple status. And you guys should know this. I know that for you to master this, I will not tell you that, I will tell you the truth, right, guys? It was also difficult for me to keep this one in mind, simply because at the time I was a student like you, we had to go online and be reading this ourselves, okay? But if I decided to bring it here, it's because it is also frequently asked sometimes. And I want you guys at least to know, right, a little bit how it works. What are the different block status? Okay. So I will explain each of them. And if you don't understand, let me know. So I just said that, we have a global resource directory from where you have some metadata, right? Some metadata of each block. So from the global resource directory, you can know who is the owner of each block. Okay, that's what I said. So this is the first scenario. The first scenario is when you are trying to read from a disk. What does it mean? It means that instance 1 is the master of a block, okay? But instance 2 actually needs that block. That means someone issue a select statement, a read operation, right? And the read operation, of course, we need a block. Instance 2 will do what? Instance 2 will go to the global resource directory, try to find the block, right? And from the global resource directory, instance 2 will know that we notice that instance 1 is actually the owner of the block is looking for. Okay, so instance 2 now will ask instance 1, please send me your block. Okay, because instance 1 doesn't have it, instance 1 will redirect instance 2 to the disk because the most recent copy of the block is on the disk. Now instance 2 has to do what? Instance 2 has to go and read the block from the disk and bring it to its memory. Okay? So in this particular scenario, whenever you are reading a block from the disk and you are bringing it back to your memory, the block status will be in share current status. You query the vidola bh_bh.status, vidola bh.status, the block will be in a shared current mode. So shared current just means that the block is as same as it is on the disk. So whenever you are just reading from the disk, right, you bring to your buffer cache, you just read. You're not updating the block yet. So the status of the block is the same as it is on the disk. So the status will be in share current mode. Okay? This is the first scenario. You read the block from the disk. The status will be shared current. Second scenario. Instance 2 actually has the block, right? You selected, you brought it to the buffer cache, and it's there in share current mode. Now, another person from instance 3 needs the block for write operation. It means that instance 2 needed the block only to read. Now, instance 3 now, someone runs a query from instance 3, right? And the query now is an update operation or a GML. That means something has to change on the block. The same scenario will happen. Instance 3 has to know where the block is. And to know where the block is, instance 3 has to contact the master of the block. The master of the block, which is instance 1, will request instance 2 to send a copy of the block to instance 3, because instance 3 is the one who needs it. So the copy of that block that is actually residing on instance 2 will move to instance 3. So now we have 2 copies in both instances. One copy on instance 2 and another copy on instance 3 for update purpose. Because instance 3 is requesting for the block to update it, the block status will change on instance 2. So whenever on one instance you have a block, but on a different instance you are trying to update the same block, on this instance the block status will change to consistent read. It's held for read consistency. So it means that when instance 3 is updating the block, we have the read consistent copy of the block on instance 2. It helps for read consistency, right? It's like the undo. When you guys want to update a block in the buffer cache, what do you think happened? Oracle will create the copy of the block, right? Will be stored on the undo table space. That is the past copy of the block. That is what will help you to hold back in case you change your mind. That's the undo copy, right? Mm-hmm. is stored in the undo table space. So when you come to update the block in the buffer cache, there's always an undo copy that's created and is stored in the undo table space. It has a lifetime undo retention. It can be overwritten after you commit your transaction. That's the same thing here. Instance 3 now, we have a copy of the block that is actually on instance 2. Because instance 3 is updating the block already, the status of the block on instance 2 will switch from shared current to consistent rate. Instance 3 now, the block that is actually owned by, that is actually residing on instance 3 will switch to exclusive current. Why is it switching to exclusive current? Simply because instance 3 is actually performing a change on the block. So you are holding the locks on that block. So you have exclusive lock on that block you are actually updating, but you have the consistent rate copy on instance 2. Once you are done with the change, what happens? You commit, right? The transaction on instance 3, the user will commit, right? Once the user commits the transaction on instance 3, it means that that block on instance 3 now is more up to date than the block on instance 2. Because it's already updated by instance 3, right? They already committed a transaction. It means that the status of the block on instance 3 now is more recent than the block that was on instance 2. The status of that block on instance 2 will change again from consistent read to past image. So after the transaction is committed on the block, the status of the block of the previous copy will change to past image. And now instance 3 now can request to instance 2 to write the block to the disk to avoid data corruption. I took those two scenarios just to explain all the 4 block status: shared current, exclusive current, consistent read, and past image. Questions? Questions?
I have a question.
Any question or
Yes, sir.
Yes.
I want us to evolve in a situation where probably we had the 4th instance. And after instance 2 updated the block, and instance 3 is still having the I don't know if it's the right term, the old copy of that block, and then probably there is a 4th instance who wishes to perform probably a read, who wishes to perform a DML on that block. Where is that instance going to read from? Is it from instance 2 or instance 3?
So if another instance needs a block to read, okay, for read purpose, that instance will get the most recent copy of the block. Okay. Now, who has the most recent copy of the block? Is it instance 2 or instance 3? That is the one that we've sent the most recent copy to the 4th instance. Does it make sense?
Where instance 2 and 3 were just reading on the block. They were just reading. None of them were writing.
They were just reading?
Yeah.
Okay. So the latest person who had the last copy of the block will send it. So if instance 3 was the last person who waited for the block to instance 2, that means that instance will send the copy to block to the next instance. Okay? I don't know if it makes sense.
I have a question, sir.
Yes.
Why is that instance 3 cannot write to the disk directly?
Instance 3 can write to the disk directly. Why instance 3 is just asking to instance 2 to write to the disk? the past image to the disk immediately. Okay, simply because we don't want to keep two blocks having different status on the memory. It's just to saturate the memory, right? For nothing. Let's assume that I have the previous copy of the block and I have the most recent copy of the block. Anyway, whenever I'm requesting for the block, RAC will always send me the most recent copy. Okay, what about the previous one? It won't be sent anymore to any connection, right? So better we just write it to the disk. But after, the GB writer will still write it to the disk. Even the one on node tray or on instant tray, the GB writer will still write it in batches, right? On the disk. And it makes sense.
Yes, sir.
Yeah,
Yes.
that's how it works. Question? Okay, so if there's no question, so we take 10-minute breaks or break, we come back, we round up with the Oracle ASM. Okay? Because ASM is another concept.
Okay, sir.
So see you guys on next 10 minutes, okay? So start with Oracle ASM to close the session. Okay, see you in a moment.
Anita. Anita.
Hi.
Okay. I got disconnected when Mr. The prof was explaining that you were actually correct. Could you give me the explanation?
So you know you have two IP, two private, and then two public, two virtual, and you have 3 scan.
That I know.
Remember for the scan listener, you know you have the scan IP.
Okay, right.
Yeah. So you know for the scan you have 3 components: the scan name, the scan IP, and the scan listener. So we said by default you have 3 scan IPs.
You mean we have 3 scan IP, like the scan copy are 3, or inside the scan we have 3 IP addresses inside?
Hello.
Yeah, you have 3 inside.
Yeah, yes, Mr. Jones.
I just wanted to chip into what Anita was explaining.
Go ahead.
So if you take 3 for instance 1 plus 3 for instance 2, and then 3 for the scan, it actually adds up to 9. And then he gave a formula that if you fall in that kind of situation, you go by the formula. It's 3n plus 3, where n is the number of instances in the scenario. So if let's say we had 4 instances, it's going to be 3n. That means 3 times 3 plus 3.
No, if you have 4, it's gonna be 4.
So,
so 4. So the number of nodes
plus 3. So,
yeah, 3 times the number of nodes
plus 3 for the scan.
People are confusing people now.
Anita. Yeah, I got the formula. So if we have 3 nodes, we're gonna multiply 3 by 3. That would be 9. Excuse me, we have 2 nodes.
If you have 2 nodes, yeah, because you know for each node you have the private, the public, and the virtual.
Right.
So that's 3 for 1 node. So that's times 2. That makes 6. And then on the scan listener, you have 3 scan IPs.
But you know that this question is very tricky, right? Because we are at some point we are not the let me say the way that we configure RAC in Brontech is very different because we have the network team that have already done everything, right? So I'm sure, like I saw the dude that was configuring it, has watched a video yesterday and today. He just used just two IP addresses.
For the scan?
Like, how would I even say it? You will never come across a place where you will see where
2 IP address because it's 2 nodes, right? Was he using? I think he was using 2 nodes, right?
Like what I'm saying is when he got to the point where he needed to put the IP addresses of the other node, he just used the public IP and the VIP. If not, the VIP was probably I've forgotten, but he just used the public IP and the other one. So have you watched the video?
Nope. I started. I haven't watched it all the way.
Right, it got to a point he just used but 2 IP addresses, and perhaps he had already run those other scripts, right?
I guess. Well, that's what I know, Bello. You can ask the teacher for more clarification.
No, I appreciate your explanation though.
Okay.
When it comes, I'm gonna ask him. I was disconnected.
Okay.
Why were you disconnected?
So we are still on Golden RAC, and on Monday, is it Monday? On Friday, I'm gonna go back to Golden Gate, then come back now to RAC.
May I finish quick?
You don't have to be there on Monday. He said it's optional. And I know you don't need to because you're a senior, future senior DBA. So.
No, I'm saying like, we have not even installed RAC, right?
Yeah, but that's for those that need it, those that are behind.
So I'm
Senior DBA wants to start working. They're wasting his time.
She said I'm a senior future.
Future senior.
That's what I say. He wants to start working. He don't want to be future anymore. He wants to be the DBA, the senior DBA at once. And if are wasting his time, I want to teach people behind.
No, it's not a matter. If you mix Golden Gate with this RAC now, boy, you don't even know it to be node now.
No, your brain will differentiate them as long as you understand the concepts.
So Bello, you say from the video that he was only putting two IP addresses. So which one do you think it was? Do you think it was the private and the public?
It got to a point where he needed to, let me say, he needed to edit the SSH script, right?
Mm-hmm.
That was when he used the file. He used the public and the visual. That was what he used to put in his SSH script.
Okay.
When he was installing the grid software.
I don't know.
And you know, Anita, he was connected in node 1. Let me say node 1 and node 2, right? Everything, as long as he edited that script, that SSH script, everything he does in node 1 it automatically reflects in the other node.
Okay.
So
Have you started the configuration?
Anita, I'm sorry, what were you saying?
Have you started the configuration?
For RAC,
Yes.
I've not even gotten the concept.
Okay. Okay.
All right. Right. Let's round up all these. Okay. So we talk about whatever we have been discussing about so far till now was cluster web related. Okay. So we're talking about cluster web, OCR, route changes, scan, cache fusion. Okay, so it was mostly instance related, resources or node related. We never discussed about the storage, right? We never spend more time on understanding how the data is organized at the storage level. So the ASM is, the storage manager. And I said last time that before a database instance goes to the storage, either to write or to read the data from the disk, the database instance has to contact the ASM instance first before you can go to the storage. So, and the ASM instance, the normal ASM instance, okay? Because we have two types of ASM instances. You have the normal that is found on any version of Oracle, 9i, 10G, 11G, 12C, 19, whatever, okay? We have the flex ASM that we'll be talking about later. So the normal ASM runs on each node. It means that when you install Oracle Clusterware on a node, on Oracle Business Infrastructure, on a node, the ASM will run on that node and any other node of the RAC environment. So if I have 3 nodes, I have 3 ASM, 1 ASM per node. And that 1 ASM per node will manage all Oracle database instances running on that node. It means if that on Oracle instance, if on that node you have 5 database instances, 10 database instances, all of them, for them to go to the storage, right, they will have to go through that single ASM instance. Okay. So, and the ASM instance the ASM itself has 2 components, the instance, right, and the ASM storage, ASM disk group. These are the 2 components, the ASM instance and the ASM disk group. Okay, so the instance is that the active part, right? That's what has the processes, the processes that will, ensure the communication between the database instance and the storage, and also some processes that will take care of the storage. And we have now the disk groups that we'll be talking about, okay, in a moment. So that ASM instance, okay, again, that ASM, it stands for automatic storage management. So it manages the storage automatically for you, okay? And it has, okay, its own home, different from the Oracle home, okay? So the home is, most of the time it can be the grid infrastructure home as well, okay? That's where all of them can be found. And it has its own instance and its own set of processes. So it has some common background processes as Oracle instance, like the PMON, the SMON, okay? But other processes that are there to manage the storage. We'll talk about a few of them. So this instance also have, its own parameter file. Okay, So you have a P5 for the ASM as well. So it's just a separate instance like the database instance, okay? It comes with a set of processes, okay? Now, what are the benefits of the ASM? What is it used for? Before I explain, you know, how important it is, I'll just show you a little bit how the data is organized at the storage level. This picture is very important, and I will keep it, you know, even to evening. So in this image, drawn, right? We have two nodes, node 1, node 2. On each node, we have one ASM instance, okay? ASM instance 1, okay? And ASM instance 2. This ASM instance 1 will manage all database instances on node 1. This ASM instance 2 will manage all database instances on node 2. So if I have QuarCL, HR instance, whatever instance you have on this node, all of them will have to go through ASM2 before they can access the storage. Okay. And those ASM instances have to coordinate, they have to communicate, right? And they also communicate through, before 12C, on 12C, all the way to 12C, right? They communicate through the interconnect as well. So they also use the private network. But still on 12C and 18C, you can decide to have a dedicated network for the ASM in order to improve, you know, GIG's performance. Okay. So then the ASM instance running on each node communicate with other ASM instances. They have to coordinate, right? When it comes to the storage, they have to communicate. Okay. So whenever, and one of the database, and now the storage part, right? On the storage part now, the shared storage. Let me show you how the shared storage organized. On the shared storage now, we have what we call disk groups. A disk group is a group of disks. Okay, and now we have separated this group. This is the shared storage, the biggest rectangle, right? And those squares are disk groups. So each disk group, we have a set of disks. By default, we have 3 types of disk groups at the storage level. Disk group for data. Let me admit someone. Disk group for data, that means what? Only the data file, right? Data file, control file, online redo. Those data file, right? We go to that disk group. Whenever you guys go online, you guys see plus. Those are disk group, right? So this group for data is plus data. The second disk group is the FRA. This group for backups only. Backups, archive logs, you know, backup as copy, flashback logs, all of them will go to the FRA disk group. And another disk group for the OCR and voting disk, they have their own disk group. So by default, you have a minimum of 3 disk groups in the RAC environment. Now you will no longer talk about directories. Directories, as you guys know, right? Because on the regular file system, in order for you to see all the data files, you just have to cd to a directory, right? Cd to /ora data, and under ora data, you will see the directory of all of, the directory of all databases, right? You will see a directory for ORCL, a directory for TLS-DMO, a directory for RCAT, and so on. Does it make sense? That is how you guys were able to identify your data files your backups, you guys were going to /oradata/FRA. And on that FRA, you will have multiple directories, right? For the backups, for the archive logs, and so on. That is the same thing. Now we talk about this group. So you can no longer CD at the operating system level to see your data. For you to be able to see these groups, you have to connect to the ASM using the command ASM command at the operating system level. So you just type ASM CMD. It will bring you to the command line of the ASM. The ASM has its own command line, like SQL, like data, like GG broker, right? When you guys were trying to connect to the data broker, you just do ggmgrl, right? / you connect to the broker. When you wanted to connect to Golden Gate, you just do ggsci, correct? You get to the command line of Golden Gate, okay? That's the same thing for the ASM. For you to be able to see this group, to visualize, right? To know exactly where the data is located, you have to connect to the ASM command line. Once you are there, you can now navigate and get to whatever this group you want to get into. And now you have a minimum of 3 this group. One this group that will store your data, one this group that will store your backups, and one this group that will store your clusterware configuration files, such as OCR and vouching file. Okay? So, and the naming convention of this group is a plus on the front. You can see here plus data, plus FRA, plus OCR. So whenever you see online, they talk about, so moving forward, right? When you will do select name from video data file, you will not see /oradata/ no, you will see plus data / the file name. I don't know if it makes sense what I just said. So if you issue, for instance, right, select name on SQL. All right, you will see something like this. Plus data / system 00 some crazy numbers .gbf plus data / 6ops some crazy numbers you cannot understand because ASM uses Oracle managed file, so you don't define the naming convention. Sometimes you can define it if you want to, but you have to disable Oracle managed file. So you also have another one, some crazy numbers .gbf, and so on. So there's no more /oradata/ database name / system01.gbf. Does it make sense? Now everything starts with plus this group name. Okay. If you want to see the backup location, video backup or whatever, you will see now for the backup, we start with plus FRA / the backup name. Does it make sense? And so on. Okay? So that's what we call a disk group. Now, a disk group is made up of disk. A disk group is a set of disks. That means we have one or more disks in a disk group. Those disks have a size, megabyte or gigabyte, right? And those disks have to be prepared by the sysadmin at the operating system level. When you will watch the video, you will see that at some point, the first script you guys will run, those scripts will help to prepare the disk on the disk group. He explains it. That's why I want you guys to watch that video. So the sysadmin will make available the disk, making sure that they are empty, they are not used yet. Now, you, the GBA, when you are creating a disk group, you will go and get those disks in order for you to create a disk group. You cannot create an empty disk group. For you to create a disk group, you need some disks available for you to create a disk group. And those disks should be made available by the sysadmin. Okay? And those disks have the same size. Depending on how big your database is or your environment is, you may need more disks. And you can add more disks if you need more. You can remove if you don't need anymore. We talk about rebalancing later. So you guys should keep in mind that each disk group has one or more disks. We have a disk group for data, a disk group for backups, and a disk group for cluster where configuration files such as OCR and voting files. Separate this group. It means that when you guys will CD to the ASM, when you guys will connect to the ASM, right, you LS, you will see all of them aligned. You will see data, FRA, OCR. So for you to get to the disk group data, you just have to CD to that. For you to go to the disk group FRA, you just have to CD to that. We are going to navigate on ASM Monday, if possible, right? If everything goes well. So that's basically how it works. Now, how is it organized? How does ASM manage those disks? This is where it's becoming important. ASM provides strapping, load balancing, mirroring. I will explain this concept before I will drop this session today. Let me start with the strapping first. Strapping means what? It means that when the data is going to the storage, when a DB writer is trying to write to the disk, the data will be shared equally among the disk present in the disk group. What does it mean? When a block is coming, the data is coming, right? One part of it will go to the first disk. If we have 3 disks, for instance, right? One part of the data will go to the first disk, another part will go to the second disk, another one will go to the third disk. So the data is shared equally. All the data cannot go to one disk only. When the data is coming to the storage, one part will go to the one disk and so on. And with this, that's what ASM takes care of, the strapping. And again, they have the same size. It means that if I have 6 megabytes of data coming to the storage, and I have 3 disks on the storage, we divide those 6 megabytes into 3, into the number of disks. That means 2 megabytes will go to the first disk, 2 megabytes to the second disk, 2 megabytes to the third disk.
Mr. Gaita, I have a question, please.
Yes.
I'm sorry, I'll have to take us back a little bit before I ask my question on ASM. You said Anita was right for our answer that it's supposed to be 9 IP addresses. So when you were giving the explanation, I got disconnected. But when I watched the video, the guy that was configuring it, he used but just the visual IP and the public IP. I don't know how you can relate that.
No. It doesn't mean when he was configuring. What do you mean?
Yes.
No.
When he was editing his SSH file, or should I call it directory, and he basically just used the 2 IP addresses, the public and the private, and the visual.
Yes, that was for the SSH.
Yes.
That was for passwordless SSH. It was just, that's what the, it helps you just to be able to SSH from node 1 to node 2 without having to put the password of the user, as you guys usually have. It's different. It doesn't mean that those are the only IP addresses each node has. Each node will have its own private for them to communicate through the interconnect. I mean, node 1 will have its own private, node 2 will have its own private for them to communicate through the interconnect. Each node will have its own public. That is what normally people can use to connect to the node as well. Each node will also have a virtual. People can also use a virtual to connect as well to a node. So that means by default, on 11G release 2 and above, mandatorily every single node has 3 IP addresses. Now, starting from 11G release 2 and above, we have the scan that comes into place. And the scan by default comes with 3 IP addresses. They don't run on a dedicated node, no. They can run from anywhere, but they are remote. So it just helps to ensure load balancing, right? Now the client can use the scan for them to be able to access the server. That's what was making the calculation. 3 for each node. If I have 2 nodes, it makes 3 plus 3. That makes 6. And the scan comes with 3 IP addresses. It makes 6 plus 3. That makes 9. And there's a formula that exists, which is 3n plus 3. I think I made mention of it, right?
Yes.
N is the number of nodes. 3 is the number of scan. That by default is 3. And this 3 is the default number of IP addresses per node. By default, we have 3 IP addresses per node. It doesn't change. But this one is the only one that can change in case you need more scan IPs. So in an interview, when they ask you the total number of IPs in a 2-node rack, just come and replace 2 here. In a 3-node rack, just come and replace 3. But you also have to be able to explain, right, how those IP addresses are allocated. I don't know if it makes sense, Mr. Koji.
Yes, sir, that's fair. I got distracted when the guy was configuring it. And
okay, yes. Please feel free to watch it multiple times. I watched that video in the past at least 3 to 4 times.
Yeah, he really did a good job explaining.
Okay, the guy is the same person who came last session to fix our issue here with the video. He was teaching project before. Okay, and he's a very good guy working for Oracle for a while. He's the one working on that server. So he's a very good sysadmin, very, very good. So even till now, he's still available for those who know him.
Okay, sir. I have, let me please ask my next question on ASM. So if you want to create you want to create a data file, right? How would you name it? Like when you're connected to the database and you want to create a data file.
There's another way. There's a way to name it. Okay, you can decide that you want to choose a particular name. There are some options that you have to specify why you'll be creating a table space or the data file. Okay, but if by default, when you were configuring ASM or when you are creating a database, right, you choose Oracle Managed File, you will no longer decide. You will no longer choose the naming convention of the data file. Okay, automatically Oracle will take care of that. It goes with the concept of multi-tenancy, right? When I was explaining Oracle Managed File on 12C, remember I showed you how crazy the file will look like if you choose Oracle Managed File. Oracle will choose the naming convention for you. So that is also valid for ASM. The ASM is also valid. When you are creating a database, you choose ASM. You also have that option to choose Oracle Managed File. if you choose Oracle Manage File, Oracle will choose the naming convention for your data file. If you don't choose it, then you can decide how you want to name your file. Okay?
Yeah, maybe you didn't understand what they asked it well. Like I'm saying, like how would you name the path? Like the path, the direction.
Oh, okay. When you create it, then you name the path plus data. If the data file, right? You name the path plus data / the file name. Okay? When you create create table space, you put a table space name, data file, you put the string, right? You put plus data / everything now start with plus data. Exactly this way. Plus data / the table space name / whatever you guys know, right? Plus data plus, you can say plus data / the database name / the file name. Does it make sense? But make sure you put plus data on the front. It's no longer / or data / whatever you guys are familiar with. You have to put this group name first, followed by the directory where you want the file to be stored, or followed by the database name. Okay? In the database ORCL, you want to create a data file on ORCL. Okay? Okay, so you do something like this. Assuming the database ORCL, right? Now you can say test01.gbf. You close the string, you put the size. That's it, right? If you want auto extend on or whatever you want, you just put it there, right? That's how you create it. Make sure you put this group name on the front where you want it to go. It makes sense now or not?
Yeah, it does. Thank you.
No problem.
So, sir, where does where the P file reside?
The P file, the SP file is on the shared storage, but the P file is local. So each node we have the P file, but the SP file is shared. Pay attention to the architecture. It's a shared environment, right? So all of them are using the same configuration file. So the SP file is on the shared storage. Okay? So if you go to disk which disk group? If you go to the data disk group, you will find the SP file. Okay? But the P file is local. Each node will have its own P file. So if you go to the node 1, a database instance, right, on node 1, you will see the P file there on Oracle Home /GBS. Okay? You will see the P file here. If you go to node 2, Oracle Home GBS of node 2, you find the P file. Okay? But the SP file will be on the shared storage. So the SP file will be on the disk group data. We navigate there, okay? Even when you guys configure it, okay, we play around with on that. We get there. I will show you where it's located. I will show you where each of those files are located. Okay.
Mr. Gata.
Yes,
Mr. Gata. Sometimes we make a change. We have to shut down the instance and create the P file for SP file. But if is share the SP file, or is it the way we go do like why we change maybe the parameter?
If you want to change to take effect on the entire SP file, definitely you will have some downtime somewhere. Okay, let's assume you want to create the SP file from the P file.
Yeah.
At some point, you have to shut down the database, right, in order for it to take effect. So you need to stop the entire RAC database. That means stop all the database instances, create the SP file from the P file, and start it back up.
Yes.
Okay. So whenever you want to create a SP file from P file, you need to shut down everything. You cannot decide that I want to shut down only instance 1, while instance 2 is running, I will create the SP file from P file and I will stop and start only instance 1. No, all of them should be stopped. You create the SP file from P file and you start everything together.
But Mr. Gatan, sometimes when we create the database, we not have the P file. If you want to just create the P file for one instance, one database instance, what you go do?
You can do, you just connect to that instance. You just do create P file from SP file. That's it.
Okay.
The P file will be created only for that instance.
Okay. Thank you. That's
Okay. So any other question? Okay. So I was talking about striping, right? It makes sense, the concept of striping. Just take it simple, right? Whenever data goes to the disk, it is shared evenly among the disk of that disk group. Whether this group has any number of disks, when the data comes, it will be divided by the number of disks. Okay. I have 10 megabytes of data going to the disk, and I have 3 disks on that disk group. You just divide those 10 megabytes by 3. Each disk will store a part of it. That means what? The implication is that each disk will have different copy of the data. Is what it means, right? Because if you are storing a part of the data, it means that the part I have, you don't have that part. And also, I don't have the part you have. So they have different data. Each disk will have different data. So it means that if I lose one disk, I will be losing data because the copy of that data is not found on another disk. Okay, so that is where redundancy comes into place. And I talk about redundancy. That definitely helped me to talk about mirroring. So we have 3 types of redundancies. External redundancy, normal redundancy, and high redundancy. External just means what? External means that we have only one copy of the data on a disk. It means that if I have if I have 3 disks like this 1, this 2, this 3, and the data comes, it is splitted, right? One part will go to each disk. It means that the data on this one is different from the one on this 2, the one on this 3. That is what external means. External means we have only one copy of the data found on one of the disks. One copy of the data found in one of the disks. One copy. This one will have a copy of the data. This 2 will have a copy, different copy. This 3 will have a different copy. So there is no copy, there is no duplicate. It's like you have only one control file or one data file, right? No duplicate copy. So that is what happens whenever you choose external redundancy while creating a disk group. So if you are creating a disk group, it means that all the disks of that disk group, we have only the copy of that data. You will not have a duplicate anywhere. So, but the next type of redundancy is normal redundancy. And the normal redundancy, we have more than one copy, one additional copy of the data. So it means we have the original copy plus a mirror copy. What does it mean? It means that if I have 3 disks, right? If I have 3 disks, the scenario I'm explaining now is without failure groups. So it means that if I have 3 disks, right? This one has some data, this 2 has some data, this 3 has some data. And in addition to that, each disk will keep a copy of the data of another disk, of the data found in another disk. So each disk will serve as a backup of another disk. Let's take the example. In this diagram, in this picture, right, this image, the green color represents the data that was found on disk 1. The black color represents the data that was found on disk 2. And the red color represents the data that was found on disk 3. But you can see here that we have duplicate somewhere. We have this same green color is found on disk 2. This same black color is found on disk 3. This same red color is found on disk 1. What does it mean? It means that in addition to the original copy disk 1 has, there's one more copy of this data that will be stored on a different disk. So we have redundancy. We have one additional copy of the data stored on another disk. Why do we do that? It will become important in case we lose one of the disks. Having these 2 copies located on a different disk, if I lose this one, right, we know that the copy of this one is found on this 2. That means my users can still use that data from this 2. Even this one in red has a copy somewhere on this 3. It means that the failure of a disk will not affect the availability of the data. Simply because we have now more than one copy of the data located on a different disk. So you have this option, this option, the option of allowing disk to keep each other copies. Me, I will copy the copy of your data. You keep the copy of. I will keep the copy of your data, okay? And you will keep the copy of my data, so that in case I fail, people can access my data through you. That's what happens in the normal redundancy. One additional copy. And in the high redundancy, 2 additional copies. That means in addition to the original copy, we have 2 more copies stored on 2 different disks. So what I just explained is redundancy without failure groups. It means that each group, each disk keeps the copy of another disk data, right? Each disk will keep the copy, the data of another disk. So in addition to my own data, I will also keep your data. Okay? I also keep a copy of your data. So, but another scenario could be to use failure groups. Instead of having disk, right, to keep each other copy, you can decide to separate another set of disk, right? Because we have this 1, this 2, this 3, right? This one was keeping a copy. This one maybe we keep the copy of the data of this 2, and vice versa. But with failure group, you can decide that you will create another set of disks. And now this one, the copy of this one will go to the disk 4, the copy of this 2 will go to disk 5, the copy of this 3 will go to disk 6. So here in this scenario, disks are no longer keeping each other copies. whether it's normal or high redundancy, they are no longer keeping each other copies. They have their own copy. But now, the additional copy will be stored on a different disk out of the disk group, outside the disk group, on a different disk in what we call a failure group. Okay, so in case I lose disk 1, people will be able to access the data through disk 4, for instance. And this is valid for high redundancy. So failure groups comes into place only when we are dealing with normal and high redundancy. We don't talk about failure groups when we are dealing with external redundancy. So that's what redundancy is all about. So ASM helps to ensure that. So how does it work? At the time of the disk group creation, you decide the type of redundancy you want to use. You choose. So when you're creating a disk group, you have multiple options to create a disk group. You can create a disk group using the ASM configuration assistant, ASMCA, or you can use the ASM command line, ASM CMD, or you can use SQL Plus. You just have to connect SQL Plus as sysASM. You don't connect as sysDBA, you connect as sysASM. Those are the multiple ways you can use to create a disk group. And at the time of the disk group creation, you can now decide the type of redundancy you want to use. If you choose external redundancy, it means that those disks, the data on each disk will not have a copy anywhere else. If you choose normal redundancy, you can now select whether you have a failure group, right? You can choose without failure groups or with failure groups. Without failure groups, it means that each disk will keep each other copy. That means I keep my own data plus the copy of your data. You keep your own data plus the copy of my data. That is normal redundancy. One additional copy on top of the original one. And for high redundancy, 2 additional copies. So everything you can take the decision at the disk group creation. And once you choose the redundancy, you can no longer change it. So if you create a disk group, you choose normal redundancy. There's no parameter to update it like that. If you decided to change it, you have to create a different disk group and just move the data from disk group 1 to disk group 2. Just migrate the data, the disk from one disk to another one. But you cannot update it. So you have to pay keen attention while creating the disk group. Know the type of redundancy you want. And that's what you guys will be doing for the configuration. You will watch the video. Maybe the guy will be choosing external. But at work, they may tell you, they will ask you to choose normal or high. Okay? It depends on the need. So that's how redundancy works. This is why I stop in the morning. And this is why I should stop at the evening. Any question?
So I asked this question and thanks very much for your explanation. It's clear.
Okay.
I think it's clear. You say the three tab, the name is the redundancy normal, redundancy higher, and the other one, I don't know if you one.
No, external. That means data do not have any copy.
External. Okay.
Normal, each disk has one more copy somewhere, and high, each disk has 2 more copies.
It's very clear, Mr. Gata. Just the name I was asking. Thank you.
Okay.
So, sir, I don't know why do we use external instead? Is it not unsafe?
Exactly. If you have more disks, right? You know the disk is money, right? If you have money, you buy more disks, right? In order to have multiple, multiple option, to have multiple copies. In order to choose normal, because normal require more disks. For instance, in order for you to configure normal redundancy, you cannot configure it if the disk group has only 2 disks. The disk group should have at least 3 disks or 4. So you see that there's a need to have more disks as well. Does it make sense? And the disks should have a bigger size. So it depends on how much you have, but it's very risky, right? Oracle recommends, for that scenario, Oracle recommends the OCR to be on a normal, the disk group, right? That's why the OCR should have normal redundancy, so that you have one additional copy of the OCR somewhere else for fault tolerance. But if you choose to have external, it means you don't want one additional copy. You rely only on backups. That's what you happen, right? You rely only on backup. So if Arman has taken the data file backup, you're good. You can perform a recovery later on. If not, then you have an outage. I don't know if it makes sense.
Yes, sir.
Yes, sir. Yes, sir. It makes sense.
Okay, good. Anything else, guys?
Oh, so sir, what about cardinality?
What do you mean by cardinality? In RAC, what do you mean by, cardinality is very broad. Cardinality can come in the scenario of tables, can come with optimizer, it can come with explain plan, it can come with multiple. That's what I want. What do you mean by, redirect it to this particular example of RAC so that I will understand better.
Like they are talking about maintaining the cardinality of the various disk group.
Cardinality of the various disk group. Maybe I don't understand what it means. Maybe.
So never mind, I will coordinate the question and ask in next class.
Yes, better. Yeah. So that I understand better the question as well. Any question, guys? Okay. So if there's no question, I located the server already. Okay, you can start practicing, watching the video. Okay, and Friday, those who have any question on Golden Gate or are we facing issues, you can have 1 or 2 hour session to discuss about it. Okay, yeah, that's it. So thank you for your time today again, and happy Thanksgiving. Let's meet on Friday and Monday. Okay.
Same to you. And what time on Friday?
Yeah. Is it a joint session or?
No. It's still separated. Okay. Morning session starting at 11 a.m. and evening class also has session that will start at 5 p.m. as usual. Okay.
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 So just get prepared for 5 p.m. It can happen that I put it at 5:15 or 5:30, but 5 p.m. is the base. All right. So thank you again. Let's meet on Friday, okay? Bye-bye.
Thank you. Bye.